Hello, good evening everyone. Welcome to बायजू एग्जाम prep. तो एक बार सभी लोग बता देंगे वॉइस क्लियर है कि नहीं है. क्विकली. थोड़ा खांसी है आज मुझे, है ना. Yes, so voice is absolutely fine. So there is no problem at all in regarding the voice. So quickly join the session. Let me share the session with all the other students as well, and you also share wherever you can, because the friends will join, then only you will enjoy the session live. Otherwise, it will look like a recorded session, like. So you should share the yes. Rishit, how are you? Good evening. So question will be from anywhere. This is a Master Blaster series because of your World Cup has started, and we have begun our World Cup with a very great start. Okay, so we have won the first match, and yesterday only we won. We had a great start. So let's our do our question series also. Good start. ठीक है, क्वेश्चन सीरीज को भी अपन उतना ही बेहतर बनाने की कोशिश करते हैं जितने अच्छे से कल हमारे इंडियन टीम के जो प्लेयर्स हैं उन्होंने मैच मैनेज किया. यस वैष्णवी, जस्ट वेट अ सेकेंड, आई गॉट इट ऑल इम्पोर्टेंट वन. Guys, so yes, so joined. Okay, so now if I talk about myself, so this is Ankit Verma, and I have done MTech from IIT Guwahati. Okay. थोड़ा यार प्रॉब्लम तो है थोड़ा वॉइस में, है ना. हाँ, तो 13 ईयर एक्सपीरियंस है एंड आई हैव डन एमटेक फ्रॉम आईआईटी गुवाहाटी एज वेल। और इतने सारे जो डिफरेंट पीएसयूज हैं उसको भी मैंने क्रैक किया है, तो उसका भी एक एक्सपीरियंस है मेरे पास। और जो सब्जेक्ट्स मैं पढ़ाता हूँ आप सभी को पता है, बोलने की जरूरत नहीं है। इलेक्ट्रोमैग्नेटिक थ्योरी कम्युनिकेशन सिस्टम के नाम से तो जानते ही हो। ठीक है, तो कम्युनिकेशन से रिलेटेड सब्जेक्ट ये भी हो गया। अब सिग्नल सिस्टम पे भी हम कोशिश कर रहे हैं कि हाँ जमा पाए अपने अच्छे से अच्छे। और इसीलिए ये आप लोगों के लिए एक नया क्वेश्चन सीरीज लेके आया हूँ, जहाँ पे आप लोग को सॉल्यूशन और प्रोवाइड किया जाएगा क्वेश्चंस के साथ, है ना। हाँ, ये थोड़ा सा गला बार बार बैठा हुआ है, तो इस वजह से दिक्कत आ रही है। ठीक है, तो ये आपका पहला क्वेश्चन है, एक बेसिक सा क्वेश्चन से स्टार्ट कर रहा हूँ। इसको चलो स्टार्ट करते हैं। व्हाट इज द वैल्यू ऑफ सर्कल? What is the value of circular convolution of the sequence x1 n 1 2 3 1 and 4 3 2 2 at y n equal to 0? चलो बताओ। बेसिक क्वेश्चन है, मतलब अभी शुरू में एक दो क्वेश्चन इजी लूंगा, फिर धीरे धीरे थोड़ा सा लेवल और अच्छा करूंगा। फ्रेश क्वेश्चन है, मे भी आप कभी नहीं सॉल्व किए होंगे, है ना। किए होगे तो अच्छी बात है, नहीं भी किए होगे तो ठीक है। चलो बताओ, व्हाट विल बी द आंसर ऑफ दिस क्वेश्चन? टाइमर चाहिए? टाइमर बिल्कुल दे दिया जाएगा आप लोगों को। 2 मिनट काफी है। लास्ट 38 सेकेंड्स। 18 आ रहा है। ओके, लास्ट 20 सेकेंड्स। एनीवन एल्स हु कैन आंसर दिस क्वेश्चन? चलो एक बार और मैं शेयर कर लेता हूँ थोड़ा इधर उधर, क्योंकि अभी स्टूडेंट ज़्यादा ज्वाइन नहीं किए हैं। टाइमिंग थोड़ा सा ऐसा रहता है कि स्टूडेंट्स के लिए मुश्किल भी होता है, बट ठीक है, हम एक्सपेक्ट तो करते हैं कि ज़्यादा से ज़्यादा स्टूडेंट आ जाएं। तो 19, 18, 22. Okay, so let's see. We want to calculate the circular convolution of one. You have to write in that way only. One row column method. Okay, like in this way. One, two, three, one, four, three, two, two. Okay, this is your x1. This is your x2. This is at n equal to 0. This is n equal to 0. So these are the two different values. Now when you multiply, simple, 4, 3, 2, 2. This should be blank and it should be multiplied like 8, 4, 4 and then 2 into 2, 4, but that 4 should come here. Now 2 blank space, 3 into 4, that is 12, 9 and then 6 and 6 and you again multiply with 1, that means 4, 3, 2, 2. So when you add it, 17, 19, 20 and 19. Okay, so this will be the value and these 1 and 4 are multiplied over here. So this is n equal to 0 and I am asking at n equal to 0, so the answer is 17. So complete circular convolution x1 n circularly convolved with x2 will give you the value 17, 19, 20, 19 and at n equal to 0 if I ask you, then it is 17. Okay, any doubt? Hello Bhaskar. Okay, Vaishnavi, you are in office. Good, enjoy. Any doubt in this question? 17 is the right answer, correct? You got it? 6, where it will be 6? 2 into 4 into 2, 8. Okay, this 2 will be multiplied with this 4, it is 8. This is 6. Okay, 6, yes. It is 6, so it is 23, 22. It is 22. Yes, it is 22. Yes, perfect. 22. 22, yes. Okay, this 2 is, first of all, you have to make a space. Like it is like a row and column method only. In the row column method, suppose I ask you to calculate the linear convolution. Suppose in the same question, I would have asked you to calculate the linear convolution. Can you tell me the answer? If I ask you to calculate the linear convolution, what will be the linear convolution? Calculate the linear convolution. 4, 11, 20, 19, 13, 8, 2. Okay, so we will multiply 4, 3, 2, 2. Then you can multiply here, you can leave it this place and then 8, then 6, then 4, 4. Then you will leave these two places and this will be 12, 9, 6, 6 and then 4, 3, 2, 2. So now you simply add it. It is 4, 11, 20, 19, 13, 8 and 2 and this will be your n equal to 0. So in this particular case, in the circular convolution, this 4 is placed here, this 6 and 6 are placed here, this 3, 2, 2 are placed here. Then it is a circular convolution. If you write this 4 here, this 6 and 6 here, then this 3, 2, 2 here, then it will become circular convolution. Yes, right. Now answer this one. Kumar, think of it. These are not basic filter questions. This is a simple DC gain questions. It is not filter question. It is a DC gain question only, Kumar. What do you mean by the unity gain? What do you mean by the DC gain? No, Rahul Rocks, your answer is not correct. Good evening, Ashok. Yes. So, what do you mean by the completely block the frequency? If a filter is not passing, okay, so completely block means it is not passing. So, completely block means not passing. So, output is zero in this case. Okay. So, here and it is passing with the gain unity means the output is considered as 1. DC gain mean Q. No, I will tell you what do you mean by the DC gain. So, first of all, because it is saying that the frequency 1 by 4 hertz is blocked and frequency 1 by 8 is passed. So, that means it is talking about the frequency domain representation, first thing. So, what do you mean by the frequency domain representation of H of omega? So, H of omega is P into e to the power plus j omega. It is shifted form and the value is 1 plus q into e to the power j0 and p into again e to the power minus j omega. Correct? Now you can also write it as q plus 2p cos of omega. Yes. Now it is given that at frequency 1 by 4 hertz or omega equal to 2 pi into 1 by 4, that is pi by 2, we have block frequency. That means h of omega will be considered as 0. So this is 0 equal to q plus 2p cos of omega is pi by 2. What is cos pi by 2? 0. So it is 0. Q plus 0. Q plus 2p into 0, and it is also equal to 0. So from here you will get q equal to 0. Yes, Ashok, q equal to 0. Now the same way at f equal to 1 by 8 it is pi by 4. So at f equal to 1 by 8 hertz or omega is equal to pi by 4, h of omega is 1. It is 1, which is 2p cos of pi by 4 plus q. So it is 1 equal to 2 into p cos pi by 4 plus 0. So 1 plus 1 equal to 2p by root 2, or p is equal to 1 upon root 2, or you can say 0.707. So what is your h of n? H of n is now 0.707, 0 and 0.707. Now, what do you mean by DC gain? The DC gain is summation n equal to minus infinite to infinite h of n. Okay, you said now, Rahul, that DC gain is 0. H of omega, if you want to define, it is summation n equal to minus infinite to infinite h of n e to the power minus j omega n. So DC means omega equal to 0. So h of 0, when you put summation n equal to minus infinite to infinite, h of n will come. So this will give you the DC gain. Okay. So 0.707 plus 0 plus 0.707, 1.414. Yes, so this will be the answer. Okay, so answer for this question is 1.414. Next. Yes, so 9 and 3, two options I have got. 4 is also close to the answer. Yes, one right. Correct, correct. Correct, Venkat. You are delta 0 is equal to 1 only. Yes, perfect. So it is a multiplication property of impulse. X is equal to 1, 2, 3. Okay. And x of k is 4 minus k and del 1 minus k. So we know that it is k equal to 1 to 3. We get the value where the impulse is occurs over here, k equal to 1. So 4 minus 1 del 1 minus k. So from here you are getting k equal to 1 to 3, 3 into delta 1 minus k. Now, if you put k equal to 1, if you put k equal to 1, it is 1 minus 1. If you put k equal to 2, it is minus 1. If you put k equal to 3, you will get minus 2. So in these value, impulse exists or not? Impulse only exists at n equal to 0. It is only existing at n equal to 0. This is delta n. And for other values of n, it is 0. So minus 1, minus 2, minus 3, 1, 2, 3, all other values will have 0 value. So it is 3 into 1 equal to 3. So answer is 3. At other points, it would be 0. Okay, these are value having 0. Okay, Kumar. Okay, now answer this one. Again, one more easy question. After that, the question is going to be tough. This is easy question. 6. Hello, Ajay. Ashok, Rishit, yes, all are getting 6 only. I'm asking at z is equal to 1. Still, I'm waiting for other people to respond because there are 13 students watching live. Root locus polar plot also. I will take root locus polar plot in the BYJU'S exam prep app. Venkat, have you joined my Telegram group? Because in the BYJU'S exam prep app, I am taking the free test on the different topics where this particular part will also come. The root locus will also come. All of you download the BYJU'S exam prep app. Link is given in the description. 0.68. So now we have h of n, 3 delta n minus 1 plus 2 delta n minus 2 plus delta n minus 3. Okay, what is the definition of the Z transform? The Z transform says h of z is equal to summation n is equal to minus infinite to infinite h of n and z to the power minus n. Okay, and the one property of the Z transform says if the x of n is having the Z transform x of z, then x of n minus n naught is having the Z transform z to the power minus n naught x of z. Okay, so we are going to use this one, the shifting property. The delta n is having the Z transform 1. The Z transform of delta n is 1. So this is 3 e to the z to the power minus 1, 3 z inverse, and the z transform of the delta is 1, plus 2 z to the power minus 2 and z to the power minus 3. So when we put z is equal to 1, so at z is equal to 1, it is 3 plus 2 plus 1 equal to 6. So directly also from here, if you can imagine, quickly you can solve. Venkat, generally I take class at 5:30 p.m. in BYJU'S exam prep app. Okay, in the BYJU'S exam prep app, where I take the mixed subject test, where control system, network, and digital, these are the combinations. That time you will get 5:30 p.m. every day from Thursday to Saturday. Okay, let's solve the next question. Venkat, you join my Telegram group also. The link is given in the description. Because I don't know about the common group, but in my group I will share the link. Link of the lecture directly will be shared in my Telegram group, my personal Telegram group. So better if you really want to attend the session, then just join my Telegram group. That would be better. ISRO mock test I am taking it this week. Thursday, Friday, Saturday. ISRO mock test I am taking. Yes, last 30 seconds. Bombay, someone is getting A. Anyone who wants to answer? If anyone need more time because you have solved, but the answer is option C. Answer is option C. Let's see how to solve it. First of all, the Fourier transform. No idea, no? Okay, so let me explain. The Fourier transform of xt can be written as magnitude and its phase. Okay, x1 e to the power j omega can be written as x1 e to the power j omega magnitude and at an angle x1 e to the power j omega, right? Or e to the power j also you can write. So let us say we have a rectangular pulse having the width 1 and mod of omega less than 3 pi. Okay, we are considering this not exactly as a triangular wave. We are considering this as a x1a e to the power j omega equal to, we are assuming one pulse having the magnitude 1 for omega less than 3a, 3 pi. What is given in this question? 3 pi. Mod of omega n. Mod of omega. 3 pi. Not 3a. 3 pi. And 0 otherwise. Okay, why I am considering? Because it is minus 3 pi to 3 pi. Here also the phase is minus 3 pi to 3 pi. We have to determine the signal xt. The signal x1t whose Fourier transform is x1 omega has magnitude and determine the signal xt. He is asking for the signal xt. So now, suppose if I take the x1 j omega is nothing but that, because we have taken the magnitude as mod of omega less than 3 pi, so we can say that our x1 omega is, okay, our x1 omega, this one, x1 e to the power j omega. Well, let me write in this way because otherwise again and again I need to write, and generally we write in this way for continuous, and for discrete only we write e to the power, na? So for simplicity I am writing in this way because writing e to the power omega takes time. So now it is 3j omega times, so mod of omega less than 3 pi and 0 otherwise. Can I write? My x1 omega is 3j omega times of x1a. Okay. At omega equal to 3 pi, the magnitude is 9 pi and the phase is pi by 2. At omega is equal to 3 pi, the magnitude of x omega is 9 pi and phase at an angle x1 omega is pi by 2. From this graph, you can see from the graph at minus 3 pi the magnitude is 9 pi and at 3 pi the magnitude is pi by 2, and minus 3 pi it is minus pi by 2 and magnitude is 9 pi in both the case. Now at at omega equal to minus 3 pi, at omega equal to minus 3 pi also, we have x1 omega is equal to 9 pi, but the angle is minus pi by 2. So is it clear up to this point? Is it clear? Now use the differential property because j omega is multiplied whenever there is a differentiation. So write x1t. So write x1t. So x1t is 3 times of d by dt of x1 a t, because if you take the differentiation of this, then you will get 3j omega. If you take the differentiation of this, then you will get 3j omega by using the differentiation. And we can also express x1 at as sine 3 pi t divided by pi t. Also x1 at as sine 3 pi t divided by pi t, because this is the in the frequency domain, na? Rectangular path is in the frequency domain, so when you take inverse Fourier transform, this will become your sinc function. So sine 3 pi t divided by pi t. So what will become your x1 t? So your x1t will become 3 into d by dt of sine 3 pi t divided by pi t. Okay. Now just you need to differentiate it. 3 cos 3 pi t multiplied with 3 pi divided by pi t plus sine 3 pi t divided by pi minus 1 upon t square. So final answer is x1t would be 3 is only common, and according to option if I go 3 pi cos 3 pi t, one option pi t square is also taken common. So pi t square if I take common, so I have to multiply with t also. So 3 pi cos 3 pi t into t minus sine 3 pi t. Yes, so option C, 3 pi t cos 3 pi t minus sine 3 pi t. Got it? Okay, coming to the next one. The response of LTI system is given if the input to the same system as shown below and response being yt, then y0. Since we are only interested in the value 0, so it can be solved little bit easily. Anyone got the answer? Okay. So the right answer is option A. Right answer is option A. X1t is equal to ut plus ut minus t. So first of all, in this question, try to understand that when we are giving input as ut and ut minus 1, then we are getting the output as gt. So this output we are getting when we apply ut plus 1 and ut minus 1. That means minus 1 to 1. This is also 1. This is my x1t. Okay. Now, if the input to the same system is x2, suppose I apply this input. Okay, suppose I apply this input, then also I'm getting the output yt. So what will be y of 0? We have to calculate. This is the LTI system. Now, if you write your x2t in terms of x1, okay, if you write x2t in terms of x1, then it is x1 t plus, it is starting from 3 by 2 minus 3 by 2. So it is t plus 1 by 2 and plus x1 t minus 1 by 2. Can I write it? Can I write like this? T plus 1 by 2. Okay, this is I am drawing x1 t plus 1 by. Okay, so in this way I am getting, just for your simplicity I am drawing everything. Okay, this is minus 3 by 2, this is 1 by 2 positive, and this is minus 1 by 2, and this is plus 3 by 2. This is your x1t minus 1 by 2, and this is your x1t plus 1 by 2. And if you add all these two signals, this first signal and this second signal, when you add, you will see this range. So this minus 1 by 2 to plus 1 by 2, the amplitude is 1 by 1 plus 1. So that will become 2, and minus 3 by 2 to minus 1 by 2, it is 1. So this is the question which is given. This is 1, this is 2, this is 0. Okay. Now, because it is a LTI system, so the shift will remain, it will give you the same shift in your output as the system is same. This is LTI system. So because the x1t, when you are giving input as x1t, you are getting gt. Okay. Now similarly, this LTI system, when you will give input as x1t minus 1 by 2, you will get g t minus 1 by 2. And if you suppose get t plus 1 by 2, you will get g t plus 1 by 2. What if I add both of them? When I am adding both of them, when I add, both of them, these two, I will get x2. So that means x2t will give me output addition of gt minus 1 by 2 plus gt plus 1 by 2. So the output corresponding to x2 is nothing but y of n. So y of n is nothing, y of t in fact. When the input is x2t, the output is yt. So yt is how much? Yt is gt plus 1 by 2 and gt minus 1 by 2. We want to calculate at t equal to 0. So g 1 by 2 plus g minus 1 by 2. Now, how do you calculate the g 1 by 2 and g minus 1 by 2? This minus 1 by 2, the slope is 2, so it will be 0.25. Okay, it will be 0.25. So 3.25. So 3.25 plus 3.25 equal to 6.5. So answer is 6.5. Okay, understood or not? How many of you understood this? By transfer function method also you can do, but ultimately somehow you have to represent it in terms of GT. Then only you will be able to tell the output because the value is depending upon the value of GT. It is you have to write the transfer function GT GS, then it will become difficult actually because if you go in the time domain then it is easy. If you go in the transform domain then for a rectangular pulse it will become tough, and corresponding output also it will be difficult to calculate. So here you have to use the property of LTI. That's why this question is taken, that you will understand that how to utilize the property of LTI. Otherwise, it would be lengthy, very lengthy and complicated also. It may be possible that you will not get answer also. Yes, this process is only easy. I have taken only few steps. This is just to make you more clear. Otherwise, it is very clear that if we have a rectangular pulse is giving output GT, then if this signal is shifted version of this, if the x2t is shifted version of x1, then the output of x2 will be shifted version of gt. Okay, if the LTI system has input x1t giving output gt, then an LTI system, same system giving input x2, which is shifted form of shifted form of x1, then the output will be shifted form of gt. That is the property that we have to use. Otherwise, there is no use of studying LTI. Yes. So definitely I will end the session. Hope you have enjoyed the session. Tomorrow also you join my session. Okay, tomorrow also you can join my session, and at 4 p.m. tomorrow also I am having class at 6:30, Venkat. So I will not be able to take the class after 5. So 4 p.m. tomorrow, more questions on signals and system. New questions. Okay? More new questions. New questions only. 1 hour session. Tomorrow also I will take, and I will cover 10 to 5 questions, but that would be fresh. Thank you. Don't forget to subscribe the channel. Let's meet tomorrow at 5 p.m. 4 p.m. Tomorrow at 4 p.m.